Today's warm-up says, if Miss Darwin pushes a 2-kilogram box horizontally for 4 meters with a force of 5 newtons, and it accelerates at a rate of 1.5 meters per second squared, what is the work done by friction? And then the follow-up question says, if this occurs over 7 seconds, find Miss Darwin's power output. So we're going to, again, just do a little bit more practice with power calculations and bringing some other stuff into that discussion. And so stuff that's not in our power equations, so that we're using, any of these equations that are on my board potentially. And then, so we're going to do a few examples with that, and then your homework or classwork really for the rest of the period, homework if you don't finish it, will be that 603 work and power review. You guys do have a quiz on Monday, okay? So please make sure that you are looking at your materials over the weekend so that you don't forget everything whenever you show up Monday morning. I don't think y'all will forget everything, but I know it's a little bit, tougher if you haven't looked at it in a few days. Your test, by the way, for this unit is next Wednesday, so that's also coming up. Okay, so let's go ahead and take a look at this question. Again, we're going to start by labeling everything. We have a mass of 2 kilograms. We have a distance or displacement, since it's just in one direction, they're the same, of 4 meters. We have a force that's applied by me in the question of 5 newtons. And we have an acceleration of 1.5 meters per second squared, and we're looking for the work done by friction. Okay, and so I need to figure out how much force of friction there is so I can determine the work done by friction, because work, of course, is force times displacement. Okay, but if I look at this scenario, it's not just friction applying a force, it's also me. Okay, and so there are 2 different forces to consider here, which means we're going to have some net force that equals our mass times acceleration, which is always true, but this net force is not force of friction because I am pushing as well. Okay, so we are going to use F net equals ma to determine the net force, and if we determine the net force, because we already know the applied force, we can find the force of friction, and then we can go and solve for the work done by friction. Okay, so the net force is going to be the mass, which is 2 kilograms, times the acceleration, which is 1.5 meters per second, giving us a net force of 3 newtons. Again, this is not your force of friction. This is the total force acting on this box. So this will help us to draw a free body diagram. Let's draw a picture. I know that that box has an applied force from me of 5 newtons. I know that the force of friction will oppose that, okay? But I don't have the number for it. However, I just determined my net force to be 3 newtons. So if my net force is 3 newtons, what does that other force have to be? 2. Okay, that other force, my force of friction, has to be 2 newtons going backwards, or -2, so that the sum of those forces, 5 plus -2, will give us 3. Okay, so again, we've done this stuff before. But this one has to be -2. So my force of friction, I know, is -2. I can now use that in order to solve for the work done by friction, because work done by friction will be force of friction times the displacement of that box, which is -2 times 4, or -8 joules. So the answer to the first part of the warm-up is -8 joules. Okay, before I go any further, does anybody have a question about this? Okay, so again, we're using some older stuff, bringing it in and applying it to this scenario in order for us to find work. Okay, the follow-up question asks us to find my power output. Okay, if I'm trying to find my power output, I need my work divided by the time. Okay, so I don't need the work done by friction. I have to find another value here. Okay, so it's important for you to keep those straight. Okay, so my work, or the work applied due to my applied force, you'd have work equals force times displacement, this time using my applied force to get my amount of work. My applied force was 5, it was in the question. The distance is 4, it was in the question. And so the amount of work that I have done is 20 joules. Okay, but I'm not looking for that. I want to know my power output. And of course, power is work divided by time. And so if I want to know my power output, I have to take my work, that 20 joules, and divide it by the time in the question, 7 seconds. 20 divided by 7 gives me a power of 2.86 watts. Does anybody have a question about the warm-up? Okay, so as we've done, we're just bringing some more stuff in. It's not new, we're just applying it in a new way. And you guys should be able to do this, even if you've never seen the problem before, it shouldn't matter. You should be able to use anything that's up here to solve those problems. Okay, let's go ahead and do some more practice with power, bringing in some more free body diagrams and things like that, like we did in our warm-up. This question says a crane lowers a shipping container onto a cargo ship. If the container experiences 1,750 newtons of tension force as it is lowered 12.6 meters to the boat in 15.9 seconds, how much work is done on the container by the crane and how much power does the crane have? Okay, so we're looking for work and power here. Let's start with the work calculation. Okay, and again, here's the information that I know. I know that that tension force applied to the crane is an upward force. I can see it in the picture, but the crate is basically only suspended due to that force of tension in the upward direction. I know the displacement of the crate is downward because it's being lowered, and so my displacement is negative 12.6, and my time is 15.9 seconds. And so if I want to find my work, again, that's going to be force times displacement, which is 1750 times negative 12.6, which gives me a work of negative 22,050 joules. Okay, pretty straightforward. All you're doing is multiplying the numbers. In this case, your main thing to focus on are those signs, because they're not labeled in the question. You have to figure out what direction everything should be in. Okay, so the first part of this one is negative 22,050 joules. And again, why is it negative? Why is the work negative?
This is negative.
Because the direction of the force and displacement are opposite. Okay, so remember, you're going to get negative work if your force is opposite the direction of your displacement. So the fact that the force is upward but the displacement is downward, you're going to get a negative value for work. All right, I put my work up here so we can refer back to it, because now we're going to do the second part of the question. How much power does the crane have? Again, power is work divided by time. I have both of those numbers, so I'm just going to divide negative 22,050 divided by 15.9, and I'm going to get a power of negative 1,386.79 watts. Okay, so again, you should be able to calculate your power. Does anybody have a question about this one? Okay. Okay, let's try another one. This one says Jenna uses a force of 173 newtons as she rows her boat to the right against a leftward current with a force of 88 newtons. If she travels 2.4 kilometers in 16.2 minutes, find the net work on the boat and find her net power. Okay, so if we're trying to solve for these things, again, when you have forces given to you and you have more than one of them, it's always a good idea to start with a free body diagram. Okay, and so I'm going to say that Jenna is applying a force of 173 newtons, and she's doing so against the current of the river, which is 88 newtons in the other direction. Okay, and so this is what my free body diagram looks like for this scenario. I drew the current to the left, hers to the right. Okay, and so from this, if I want to find net work, I do need to determine net force. You're welcome to find the work done by Jenna, the work done by the river, and then add the works together. Okay, or if you just determine the net force, you can solve for your net work just by plugging that number in and only doing it once. So that's obviously faster. So looking at these two values, again, my net force is the sum of my forces, keeping in mind that forces are vectors. So when I add them, it's 173 plus negative 88, meaning I am subtracting, which gives me a net force of 85 newtons to the right. Okay, and so if I want to determine the net work, again, work is force times displacement, and you're going to use net force if you're looking for net work. And so that's going to be 85 times 2.4 kilometers. Anybody see any issues with that? Because you should. What's wrong? Can't use kilometers. Okay, so you need to do that conversion. There are 1,000 meters in a kilometer, so 2.4 kilometers times 1,000 will give me 2,400 meters, and now you can multiply it. Okay, so check your units just in case, but 85 times 2,400 is 204,000 joules. So that's how much work she does, quite a bit, because she's going 2.4 kilometers. Okay, so she has, or that's the net work rather, on the boat, 204,000 joules. Again, net power. Okay, if we want to determine that, again, work divided by time. We already have the net work. We also know how long this takes her, 16.2 minutes, so we should be able to divide. However, can I divide by minutes? No, please tell me no. Okay, you can't. So you have to do a conversion again. There are 60 seconds in a minute. So all you need to do is multiply that number by 60, which gives you 972. Now you can divide. Okay, and so now we have 204,000 divided by 972, and that gives us the net power is 209.88 watts. Questions about this one? Okay. Just to review real quick this concept, it says Suki pulls two identical suitcases across the same surface with equal applied forces as shown. Okay, so we have her pulling the suitcase horizontally, we have her pulling the suitcase at an angle, but in both cases she's using 50 newtons of force. When does she do more work? Or is it the same?
It's the same.
What do y'all think? When she pulls it horizontally, she will do more work. Okay, because again, when we're calculating work, you can only use the portion of that force that is parallel to your displacement. So she's using all 50 newtons to do work in the image on the left, but the one on the right, again, as a reminder, it's been a while since I asked you this question, but the one on the right, only a portion of that force. I'd have to calculate it with trig, I'd need an angle. Okay, but I know that it's less than 50 because I know that whenever I draw in that right triangle, the hypotenuse is the longest. Both of the legs will be less than 50. So less of her force is in the horizontal direction, therefore less of her force is able to do work. So just a reminder, because we've asked you that before, but it's been a little while. Okay, so let's put some numbers to it. Different picture. This is Celeste. Celeste pulls her suitcase east through an airport with 73 newtons of force at 51 degrees above the ground. If she travels 0.7 kilometers in 8 minutes and 20 seconds, find her work and her power. Okay, so if we take a look at this, we have her force. I've already drawn it here. Again, we can only use the x component because that is the only portion of her force that is parallel to the displacement. That vertical piece doesn't do work. Remember, if you carry something, you're not doing work. Okay, you're doing work only when your force is parallel to your displacement. So we can't use that 73 newtons in our calculations, other than to find the component. Please don't plug it in, though, to the rest of the calculation. Okay, unless you're plugging it in here. Okay, so if you're plugging it in here, then you're already finding the component, because when you do your force, 73, times the cosine of 51, you are finding Fx. Okay, so you can plug it in if you use that dot product equation, FD cosine theta. Otherwise, find the component and then just multiply it by the displacement. Okay, so 73 times 0.7 kilometers times 51 degrees. Again, we have the same problem we did last time. I can't leave kilometers in that question. Okay, so I need to convert it to meters, multiply by 1,000, and that is, of course, 700 meters. So 73 times 700 times cosine 51. Again, that's going to give me the component of my force that is horizontal multiplied by my displacement. You can do it all in one equation, or you can do it in two steps. Find the component and then multiply by the displacement. Regardless of which way you do it, you should get the same answer, 32,158.3 joules. Questions about the first part of this one? Okay, so just kind of reviewing stuff we've looked at because it's been a while since we did some of this. All right, power is work divided by time. We just found her work, 32,158.3. Now we divide by her time, but I don't want to leave it like that. I can't use minutes and seconds. I need to figure it out just in seconds. Okay, 8 minutes, 20 seconds is 500 seconds. And so now I can divide 32,158.3 divided by 500 gives me 64.3 watts. Everybody okay with this one? Again, all of this should look familiar. We've done it before. Okay, then for the rest of the class period today, you now have a chance to make sure you can remember how to do them on your own. As you work through the assignment 603 Work and Power Mixed Practice, you have possibly already started this assignment because I've told you about it, I don't know, last week. Because remember, this is also your daily grade redo. So if you ended up with something being just a really low grade, you can get that up to a 70 by just completing this. It's your assignment anyway. So everybody should be completing it.
Does it have to be due today? Because it is reviewed maybe later in the weekend.
It's due by 11:59 p.m. tonight. So work on it. But yeah, you can keep looking at it over the weekend. You can still review with it in practice mode, or you can use a late pass to go back in and open it. It doesn't make your grade lower if you've already done it. So you can continue to use it to study, but you do have a quiz on Monday, you do have a test on Wednesday. As a reminder, I mentioned this before, but we are going to have bonus available on the test. So you will have a bonus question that you can attempt in order to earn bonus points. So if I were you, I would go back and review some of our warm-ups. Maybe the one today, definitely look at the ones from the 4th and the 5th. And then, of course, if you have other calculations that are similar to those in the problem sets or in our notes, you can look back at those. But all of those are going to be good things for you to look at as you're trying to prepare for the type of question you're going to see for the bonus points on your test. Okay, so go ahead and get to work on this mixed practice. If you have questions as you're working, please let me know.